Good morning, students. This is video 8 on classification. This is a video you should watch sometime on Monday, September 28th, to be able to stay with the homework as being assigned in the new homework packet. So I'm going to share my screen with you and teach as if I were together in class with you. So, by the time you're watching this video, you would have completed in class as an activity in different breakout rooms. This POGIL, a POGIL is an interactive group learning experience. POGILs are very important to be done in group. You learn this material by asking questions together. So I hope this was a positive experience for you, and you should have all turned in copies of page 2, 3, and 4 of the pink packet, Classification of Matter. By the end of that POGIL, everyone in your team should very clearly appreciate the difference between these words: particle, atom, molecule, pure substance, mixture, element, compound. Those are words that are oftentimes interspersed, confused, used synonymously, but they are distinct ideas that I hope the POGIL would have clarified for you. So we are on chapter 1, and it is going to smell and feel like chemistry. Matter and change. We will jump into another chapter to do a little bit of energy, specifically calorimetry. This concept map explains that the chapter really has two big ideas. We will be looking at matter for the first 3 or 4 days, actually maybe 5. And then we'll move into energy. I think energy is the more challenging for students, so make sure you're well acquainted with matter to be able to devote time when we get to energy. You're learning your elements and their symbols. Remember, I was saying that some elements are based on Latin. They're based on Latin, which was the language of science in the past. So these 10 elements, known to the ancients, would have unusual symbols. Make sure you're comfortable with them. Here is a new idea for you that you need to learn and use every time we talk about the elements. Most of the elements exist as individual atoms. These atoms are distinct from each other. But these 7 particular elements are diatomic. That means 2 atoms are bonded together to make like this set of conjoined twins. 2 atoms are bonded together, and these elements are always found as that diatomic particle. I call them the Hofbrinkel twins because it helps you remember which 7 elements are in this diatomic, naturally occurring state. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Hofbrinkel, 7 diatomic elements. Whenever you represent those elements, you need to draw them as 2 atoms touching to represent a molecule of that element. A sign I have on the side of the room that I need to point out to you is this 3 views of chemistry. When you're doing chemistry, one way you can think about and see chemistry is on the macroscopic scale. That means you're looking at eyeball chemistry. When you think of water, you're looking at an ice cube or a glass of water, a beaker of water. What your eyeballs see is one view called the macroscopic view. But then in chemistry, we switch to the very particle. What is that water made up of? If I could somehow look closer and closer and closer at the water, I would eventually get down to one smallest particle that represents what water is. And here for water, it would be the H2O molecule. That's called the particulate view. Draw me particles, think about the particles colliding. And then finally, this third view is just enough to confuse you. We have a symbolic view of chemistry in which we write symbols as if it's a new language to represent the idea that we're thinking about. This symbol represents both the particle idea and the macroscopic idea. So the three views of chemistry are important for you to always hold in mind. It is a big key to being successful in the chemistry course. You can think of hydrogen as a balloon of this invisible gas. That's what you would see macroscopically. But you can also think of hydrogen inside that yellow balloon as diatomic particles, molecules made up of two of the same atoms bonded together. This is a particular view of the diatomic element hydrogen. On the outside, they've represented only oxygen, even though if it were air, there'd be more than oxygen in it. Oxygen is another one of the Hofbrinkel twins, such that they have two atoms of oxygen bonded together to represent a particle, molecule of oxygen. But when that reaction occurs, there is an explosion and water is made. So you could think about seeing this explosion. You can think about seeing the explosion in symbolic terms, and you can think about the particles that are left at the end of that explosion. These particles are representing H2O. So now I'm going to go through a lot of classification schemes for you. Each one is giving you a different insight. You certainly don't have to duplicate or talk to me about all of these, but I make them available here because I want you to read them and think about them as if it's a textbook. This is deep understanding that you need to do for classification. I have also posted all of these classification schemes as slides in Schoology. The point of looking at all these classification schemes will be to understand these types of terms. I'm going to share my screen and show you one activity that you'll do for homework tomorrow. On page 5 in the homework packet, you'll need to identify from the classification scheme what representatives are characterized by these terms. So you'll need to know what the difference is between a substance or material, what hetero and homogeneous means, what it means to be of constant or fixed composition, what these separating techniques are accomplishing of our classified materials. All of these terms will come to you as you study the classification scheme. So I'll go back to my other slides and continue with the classification schemes. So, several important terms: heterogeneous, homogeneous, uniform properties, fixed composition. Are they chemically decomposable? You will look into all of these terms as you study classification schemes. So this is the most common, the most simple. This is the basic format to have in your mind. But I will go quickly through looking at all of those classifications from a particulate nature also. What do these particles tell you about the different classification schemes? How are these all representing pure substances? And these particle diagrams are all representing mixtures. This classification scheme gives you a little bit more information. Stop the video and read it, or go to the slides in Schoology and study them. Another classification scheme, slightly different orientation. Where do you put homogeneous mixtures, which are called solutions? I'm going to just go through these classification schemes here. You should read and think about every division point in this scheme. Read the material. Even more material to read. I appreciate this with the particle diagrams at the bottom. Notice how when we think of chemistry, we're always thinking of the macroscopic, the particulate, and then we start writing symbols that represent these particles or the macroscopic that we're talking about. Hold all three views of chemistry in your mind. Another classification scheme of matter. This one's interesting. It still breaks down the categories, but in an interesting way. I appreciate here this axis talking about more ordered to more disordered, and the vertical axis talking about specific to general. So many ways you can look at classification schemes. There's a lot of material for you to be comfortable with here. When you try to classify matter, hold something up and say, what is this? You oftentimes ask yourselves questions and it gets you through the classification scheme. Is the matter uniform throughout? That lets you go to one category or the other. Does it have variable composition? Again, if you know what that term means, it allows you to go to one of these two categories. Can it be separated into simpler substances? Another key question to allow you to distinguish elements from compounds. Keep looking at these classification schemes. Read them carefully. Of course, we'd like to think that you could stop at elements and compounds, but as you'll learn in another chapter, even elements can be further broken down. And we won't be going into this right now, but it's interesting to think how small can we see? So I am going to introduce safety in the laboratory with two videos that you'll be watching. I'll also teach the use of the Bunsen burner to those students who are in the lab. This is the end of video 8 on classification. A lot for you to look at either in this video or on the slides in Schoology. Thank you for your time.